Hello everyone, this is Dharamveer sir here. So today we are going to continue with chapter 16 of grade 11 maths, which is probability. In the previous part we learned about events associated with the sample space of any random experiment. In this part we are going to learn about axiomatic approach to probability. So let's start. So what is an axiomatic approach to probability? So we know that S is the sample space related to any random experiment. The probability P is a real valued function, that is the value of the function will be real, whose domain is the power set of S. I hope you remember the meaning of power set. Power set is the collection of all the subsets of a particular set, and range is the interval 0 to 1. Closed interval 0 to 1, that is the probability can be equal to 0, can be equal to 1, and any number between 0 and 1, that is it cannot be less than 0 and more than 1. So axiomatic approach is that the probability P must satisfy the following axioms. First is that for any event E, the probability of E is greater or equal to 0. The probability of the sample space is equal to 1. And if E and F are mutually exclusive events, let me tell you the meaning of mutually exclusive. We learned this in the part 1, that two sets are said to be mutually exclusive if their intersection is phi. So if E and F are mutually exclusive events, then P E union F is equal to PE plus PF. Clear? So pause and note down these 3 points. Now, what is the probability of equally likely outcomes? As we have learned in the earlier classes, that if S is the sample space and E be any event, such that the number of elements in S is n and number of elements in the event set E is m, then the probability of the event E will be equal to m upon n, that is where m is the number of favorable outcomes E and n is the total number of possible outcomes. Clear? So pause and note down this point. Now coming to the addition rule of probability. Like in the chapter sets, we have learned that A union B is equal to NA, and A union B is equal to NA plus NB minus NA intersection B. So same is the case for probability, that if A and B are any two events in the sample space S, then the probability that at least one of the events A or B, or means union, will occur is given by PA union B is equal to PA plus PB minus PA intersection B. Now note on this point, because this formula is very useful in calculating the probability of events A or B. Okay. Similarly, in case of three events, we can have PA union B equals to PA plus PB plus PC minus PA intersection B minus PA intersection C minus PB intersection C and plus PA intersection B intersection C. Clear? So pause and note down this very important point. So keeping all these points in mind, let's start exercise 16.3. Now question 1 is, which of the following cannot be valid assignment of probabilities for outcomes of a sample space S is omega 1 to omega 7. Now we have total 5 cases A, B, C, D, E, and we have omega 1 to omega 7, and we have to check that which of these A, B, C, D, E will not be the valid assignment of probabilities. So first we have A. Now all the probabilities of omega 1 to omega 7 are positive. So let us add. Now adding all these, we are getting that omega 1, that is 0.1, 0.2, 0.5, 0.3, 0.1, 0.2 up to 0.6, sum up to 1. And since the sum of the probability is 1, therefore the assignment is valid. Clear? Now C. Now it is clear that all the assignments from omega 1 to omega 7 are positive and less than 1. So adding them, we get 0.1 plus 0.2, 0.3, 0.4, 5, 6 and 0.7. It is equal to 2.8, which is not equal to 1. So since the sum of all the probabilities is not equal to 1, therefore the assignment is not valid. In part D, it is clearly visible that one of the assignments that is negative. minus 0.1, and we know that the probability of any event cannot be negative, hence this assignment is not valid. Moving to question 2. A coin is tossed twice. What is the probability that at least one tail occurs? At least one tail occurs. So when a coin is tossed twice, the total number of outcomes are 4. And the outcomes can be written as HH, HT, TH and TT. So the sample space S equals to HH, HT, TH and TT. Now we have to find the probability that at least one tails. So it can be E equals to HT, TH and TT. So total number of elements in E is equal to 3. So using the formula NE is equal to PE is equal to NE upon NS, we get probability of the event as 3 upon 4. Clear? So pause and note down the solution. Moving to question 4. A card is selected from a pack of 52 cards. How many points are there in the sample space? Calculate the probability that the card is an ace of spades, and C is calculate the probability that the card is an ace or a black card. So when a card is selected from deck, we know that 52 cards are there, and all these 52 are equally likely possible outcomes. So first is how many points are there. Now we know that in case of cards the total outcomes will be 52. So number of elements in the sample space will be 52. Now second is calculate the probability that the card is an ace of spade. Now let E is the event that card is an ace of spade. We know that only one ace of spade is there, so NE is equal to 1. So using the formula PE is equal to NE upon NS, we get probability equals to 1 upon 52. Now part C. Let F be the event that card is an ace card. We know that there are 4 aces in the pack. So NF equals to 4. So using the formula PF equals to NF upon NS, we get 4 upon 52, which is equal to 1 upon 13. And second, we have to find the probability that the card is black. So let G be the event that the card is black. So we know that there are 26 black cards, 13 clubs and 13 spades. So NG equals to 26. So using the formula PG is equal to NG upon NS, we get 26 upon 52, which is equal to 1 upon 2. Clear? So pause and note down the solution. Moving to question 6. There are 4 men and 6 women on the city council. If one council member is selected from a committee at random, how likely is it that it is a woman? Now we have total 4 men and 6 women. So total number of council members is equal to 10. Now let E be the event that the woman is selected. So using the formula PE equals to 6C1 upon 10C1, we get 6 upon 10, that is 3 upon 5. What is 6C1? 6C1 is that we have selected one woman out of 6. And what is 10C1? That is we are selecting one from the total 10. We learned this in the chapter combination. Okay, so pause and note down the solution. Moving to question 9. If 2 upon 11 is the probability of an event, what is the probability of not A? Now we know that P not A is equal to 1 minus PA. I hope you remember that PA plus PA dash equals to 1, or PA plus P not A is equal to 1. So using that we get P not A is equal to 1 minus PA, which is equal to 1 minus 2 upon 11, which will give 9 upon 11, which will be the required probability. Clear? So pause and note down the solution. Moving to question 10. A letter is chosen at random from the word assassination. Find the probability that letter is a vowel, a consonant. Now the word assassination has 13 letters. You can count them. Total number of letters is 13, and out of which 6 are vowels and 7 are consonants. So we have 6 vowels and 7 consonants. So probability of the vowel will be favorable 6 upon total 13, and probability of the consonant will be favorable 7 upon total 13. Clear? So pause and note down the solution. Moving to question 12. Check whether the following probabilities PA and PB are consistently defined or not. So we have PA equals to 0.5, PB equals to 0.7, and PA intersection B is equal to 0.6. Now we know that PA intersection B less than A and PA intersection B less than B. So we must have PA intersection B less or equal to PA and PA intersection B less or equal to PB. So here PA is equal to 0.5 and PA intersection B is equal to 0.6. So we have PA intersection B greater than PA, which is not true, therefore it is not consistent. Clear? And second part is we have PA equals to 0.5, PB equals to 0.4 and PA union B equals to 0.8. Now for consistency we need the value of intersection. So we need to find the value of PA intersection B. So using the formula PA union B equals to PA plus PB minus PA intersection B, where PA is 0.5, PB is 0.4 and PA union B equals to 0.8. Putting this value in the relation 1, we get PA intersection B equals to 0.1, which is possible because here we have PA intersection B less than both PA and PB. Therefore, the possibilities PA and PB are consistently defined. Done? So pause and note down the solution. Now moving to question 14. Given PA is equal to 3 by 5 and PB equals to 1 by 5. Find PA or B if A and B are mutually exclusive events. Now it is given that A and B are mutually exclusive. It means their intersection, that is A intersection B, will be equals to what? 5. So PA intersection B equals to 0. We need PA union A or B, which is equal to PA union B. And we know the formula PA union B equals to PA plus PB minus PA intersection B. So putting the values 3 by 5, 1 by 5, 0, we get probability of A or B equals to 4 upon 5. Done? So pause and note down the solution. Moving to question 16. Events E and F are such that P not E or not F equals to 0.25. State whether E and F are mutually exclusive. Now we have P not E or not F equals to 0.5. That is P A dash union F dash equals to 0.5. So using De Morgan's law, we can write P E intersection F dash equals to 0.5. We used De Morgan's law. So this will be 1 minus P E intersection F, which is 0.25. So P intersection F equals to 1 minus 0.25, that is 0.75, which is not equal to 0. And since the probability of E intersection F is not equal to 0, so therefore they cannot be mutually exclusive. Done? Because for the events to be mutually exclusive, their intersection should be 5. And if intersection is 5, their probability should be equals to 0. Clear? So pause and note down the solution. Moving to question 18. In class 11 of a school, 40% of the students study maths and 30% study bio. 10% of the class study both maths and bio. If a student is selected at random from the class, find the probability that he will be studying maths or biology. Now we have done sums like this in chapter 1 also. Now let M, a student studies maths, and B the case that the student studies bio. So PM is 40%, that is 14 upon 100. PB is 30%, that is 30 upon 100. And the P intersection F is 10 upon 100. Now PM or B, we need to find that now. So using PM union B equals to PM plus PB minus PM intersection B, we get 40 upon 100, 30 upon 100 minus 10 upon 100, which is equal to 60 upon 100. That is the probability that the student will be studying maths or bio is 0.6. Done? So pause and note down the solution. Now moving to question 19. In an entrance test that is graded on the basis of 2 examinations, the probability of a randomly chosen student passing the first exam is 0.8 and the probability of passing the second exam is 0.7. The probability of passing at least one of them is 0.95. What is the probability of passing both? Both means we need to find intersection. So let E1 be the case that the student passes first exam and E2 be the case that the student passes the second exam. We have PE1 0.8 and PE2 0.7. This is given. Now PA student passes at least one exam. That is PE1 or E2. This is given to be 0.95. So we have individual probabilities and we have the union. So using the property PE1 plus PE2 minus PE1 intersection E2 equals to PE1 union E2, we get 0.8 plus 0.7 minus PE1 intersection E2 equals 0.9. And solving this, we get the value of PE1 intersection E2 as 0.55, which is the required probability that the student passes both the exams. Clear? So pause and note down the solution. Moving to question 20. The probability that a student will pass the final exam in both English and Hindi is 0.5 and the probability of passing neither is 0.1. If the probability of passing the English is 0.75, what is the probability of passing the Hindi exam? So let E be the event that the student pass in English and H is the event that the student pass in Hindi. It is given that passing both in Hindi and English at their intersection, P intersection H equals to 0.5 and passing neither Hindi nor English at P E dash intersection H, that their P E dash intersection H dash is 0.1. So P is 0.7, P E dash intersection H dash 0.1. So using De Morgan's law, P E dash intersection H dash can be written as probability of E union H dash whole dash. So 1 minus P E union H equals 0.1 or P E union H equals to 1 minus 0.1, that is 0.9. So using the formula, P E union H equals to P E plus PH minus P intersection H, this is equal to 0.9 and put the values. We get PH equals to 0.65, that the probability that the student will pass in the Hindi is 0.65. Clear? So pause and note down the solution. With this we end the exercise 16.3. So solve the remaining sums and don't forget to solve the examples. Thank you and all the best.